Universal law of gravitation. Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of two objects. Let two objects, capital letter A and capital letter B, of masses capital letter M and small letter m, lie at a distance of small letter d from each other as shown. Let capital letter F be the force of attraction between two objects. According to the universal law of gravitation, F is directly proportional to the product of masses and inversely proportional to the square of distance. F is equal to capital letter G, product of masses, by d square. Capital letter G is equal to Fd square by product of masses. G is called a universal gravitational constant because its value does not depend on the nature of intervening medium or temperature or any other physical variable. SI unit of capital letter G is equal to Newton meter square by kilogram square. Value of capital letter G is equal to 6.673 into 10 raised to minus 11 Newton meter square per kilogram square, found by Henry Cavendish. Free fall. When an object falls down towards the earth under the gravitational force alone, we say the object is in free fall. The velocity of a freely falling body changes and is said to be accelerated. This acceleration is called acceleration due to gravity, denoted by small letter g. Unit is meter per second square. As F is equal to mass into acceleration, that is, A is equal to g, step 1, F is equal to mg, step 2, and F is equal to capital letter G, product of masses, by d square, from universal law of gravitation, step 3. From second and third step, mg is equal to capital letter G, product of masses, by d square. Small letter g is equal to capital letter G, capital letter M, by d square. M is equal to mass of the earth. D is equal to distance between the object and the earth. G is equal to gravitational constant if the object is placed on the earth then. Small letter d is equal to capital letter R. R is equal to radius of the earth. G is equal to capital letter G, capital letter M, by capital letter R square. That is, small letter g is inversely proportional to the square of the distance. Fourth step. Earth is not a sphere. It is flattened at the poles. Hence, Rp, radius at the pole, and Re, radius at equator. Re is greater than Rp. G is inversely proportional to R square. The value of small letter g is more at the poles. that is equal to 9.9 meter per second square, and less at equator 9.8 meter per second square. Calculation of value of G. G is equal to cap letter G, cap letter M by R square. Cap letter G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. Cap letter M is equal to 6 into 10 raised to 24 mass of the earth. Cap letter R is equal to 6.4 into 10 raised to 6. On substituting the given values, small letter G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square into 6 into 10 raised to 24 kg by 6.4 into 10 raised to 6 the whole square. Small letter G is equal to 9.8 meter per second square. Motion of objects under the influence of gravity does not depend on the mass of the body. All objects, small, big, heavy, light, hollow, or solid, fall at the same rate. The three equations of motions are: first, V is equal to U plus AT, S is equal to UT plus 1 by 2 AT square. V square minus U square is equal to 2AS are true for motions of objects under gravity. For free fall, value of acceleration is equal to G is equal to 9.8 meter per second square. If an object is just let fall from a height, then in that case U is equal to O and A is equal to G is equal to 9.8 meter per second square. If an object is projected vertically upward with an initial force, then A is equal to minus G is equal to minus 9.8 meter per second square, as the object will go to a maximum height h, where its final velocity becomes 0, that is V is equal to 0. The motion of moon around the earth, the motion of planets around the sun, the tides due to the moon and the sun. Object can change from one place to another, from one planet to the other. Weight of an object on moon is given by the formula W subscript m is equal to gmm into m by r square m. Wm is equal to weight of the object on moon, mm is equal to mass of the moon is equal to 7.36 into 10 raised to 22. Rm is equal to radius of the moon is equal to 1.74 into 10 raised to 6. Cap letter G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. Wm is equal to G 7.36 into 10 raised to 22 kg into m by 1.74 into 10 raised to 6 meter the whole square. Wm is equal to 1.474 into 10 raised to 10 g into m, and W is equal to 1.474 into 10 raised to 11 g into m, that is Wm by We. Weight of the object on moon, weight of the object on earth is equal to 2.431 into 10 raised to 10 gm by 1.474 into 10 raised to 11 gm, that is 1 by 6. Weight of the object on moon is equal to 1 by 6 the weight of an object on the earth. Thrust. It is the net force applied in a particular direction. Its SI unit is Newton. Pressure. It is a force per unit area. Pressure is equal to thrust by area. SI unit is equal to Newton per meter square is equal to Pascal, PA. Pressure in liquids. All liquids and gases are fluids as they can flow. The pressure exerted by a fluid is transmitted in all directions. Buoyancy. The upward force exerted by water fluid on the body is known as upthrust or buoyancy. The magnitude of the buoyant force depends on the density of the fluid. A is equal to wooden block, B1 is equal to beaker with tap water, B2 is equal to beaker with salt water. The buoyant force exerted in B2 is more as compared to B1. It is because the density of B2 water is more. The object may float, sink, or remain half submerged and half above water. The density of the fluid and objects decide this. If the density of object is less than the fluid, then it will float on liquid. If the density of object is more than the liquid, then it will sink in the liquid. If the density of the object is same as the density of the fluid, then it will half float and half sink. Archimedes principle. When an object is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Its applications are used in designing ships and submarines, in lactometers to find purity of milk, in hydrometer to determine density of liquid. Relative density. Relative density is equal to density of substance by density of water. It has no unit.